Have you ever noticed the small curved panels on the front edge of an airplane wing? They might look like just another part of the wing, but these panels play a surprisingly important role in how airplanes fly, especially during the most critical moments of flight. These are called leading-edge slats. They're specially designed movable surfaces that sit right at the front of the wing, almost hidden when not in use. Slats are crucial for takeoff and landing, helping the wing perform better at slow speeds. When a plane is moving slowly, like during takeoff or as it comes in for a landing, the risk of stalling increases. That's where slats come in. When needed, the slat moves forward, creating a gap that changes the wing's shape and lets air flow through. This clever mechanism allows the wing to maintain smooth airflow, even at higher angles, which is essential for safe flight at low speeds. This small adjustment makes a huge difference, allowing the wing to generate more lift at lower speeds. By delaying the point where the airflow separates from the wing, slats help prevent stalls and give pilots more control during those critical moments. Most of the time, slats are tucked away, invisible during cruise. When the plane is flying fast and high, the wing doesn't need the extra help, so the slats retract smoothly back into place, keeping the wing streamlined and efficient. But during takeoff and landing, they extend to help the plane lift off quickly and land gently. You might even spot them moving if you're sitting by the wing during these phases of flight. Think of slats as the wing's secret helpers, making flight safer and more efficient. They work quietly in the background, but their impact is huge, especially when it comes to keeping passengers comfortable and secure. Next time you're at the airport, look for these hidden heroes on the wing's leading edge. You might notice them as you board or while waiting for takeoff, ready to spring into action when needed. They're a simple idea that solves a big problem in aviation. By allowing planes to fly safely at slower speeds, slats have made modern air travel smoother and more reliable for everyone. Slats are a testament to the clever engineering that keeps us flying safely. The next time you fly, remember the small but mighty slats working just ahead of your window, quietly making your journey possible. Airplanes need speed to fly, relying on the flow of air over their wings to generate lift and stay aloft. But as they approach the ground, they must slow down to land safely, which presents a unique challenge for pilots and engineers alike. Slowing down too much can make it difficult for the wings to produce enough lift, yet landing at high speeds is dangerous and requires much longer runways. This is where slats come in. Slats are special devices on the leading edge of the wing that allow wings to generate lift even at lower speeds, making slow and safe landings possible. As a plane slows down for landing or prepares for takeoff, the pilot raises the nose, increasing the angle of attack to keep generating lift. But if the angle becomes too steep, the smooth airflow over the wing breaks away, causing a stall, a sudden loss of lift that can be dangerous, especially close to the ground. Slats help prevent stalls by channeling fast-moving air over the wing's surface, keeping the airflow smooth and attached even at higher angles of attack and lower speeds. Thanks to slats, planes can safely take off from shorter runways and land at airports with limited space, opening up more destinations and making air travel more flexible. Slats work together with flaps, another lift-enhancing device at the back of the wing, to boost lift even further. This teamwork allows even the heaviest planes to get airborne quickly and safely. When slats are retracted, the wing becomes sleek and streamlined, perfect for fast, fuel-efficient cruising at high altitudes. But when extended, the wing transforms, ready for slow, controlled flight during takeoff and landing, adapting to the needs of each phase of flight. This remarkable flexibility is why slats are a standard feature on modern airliners, playing a crucial role in both safety and performance. By giving pilots precise control over lift and speed, slats help ensure every takeoff and landing is as safe as possible, no matter the conditions. Though often overlooked, slats are truly the unsung heroes of flight safety, quietly working behind the scenes to keep every journey smooth and secure. To understand how slats help airplanes fly, let's first explore how wings generate lift in the first place. The science behind flight is both fascinating and elegant, and it all starts with the unique shape of the wing. Wings are designed with a curved upper surface and a flatter lower surface. This shape, called an airfoil, forces air to travel faster over the top than underneath, creating a region of lower pressure above the wing and higher pressure below. The difference in pressure generates an upward force, lift, which is what allows the airplane to rise off the ground and stay in the sky. But there's a catch. At slower speeds or when the pilot raises the nose for a steep climb, the angle between the wing and the oncoming air increases. If this angle gets too high, the smooth flow of air over the wing can break away, causing a dangerous condition called a stall. This is where slats come in. Slats are clever devices mounted on the front edge of the wing. When deployed, they slide forward to open a narrow gap, or slot, at the wing's leading edge. This slot channels fast-moving air over the top of the wing, energizing the airflow. By injecting this energetic air, slats help keep the airflow attached to the wing's surface, even when the wing is tilted at a steep angle. This means the wing can keep producing lift at lower speeds and higher angles than it could otherwise. The result? Pilots can safely take off from shorter runways and land at slower speeds, all while reducing the risk of stalling. Slats give wings a much wider range of safe operation, especially during the most critical phases of flight. It's important to note that slats don't create lift by themselves. Instead, they work together with the wing, helping it perform better in challenging conditions like turbulence, heavy rain, or gusty winds. By managing the flow of air, slats allow wings to operate efficiently and safely during takeoff, landing, and even in rough weather. They're a key reason modern airplanes can handle such a wide variety of situations. This small but ingenious design has a massive impact on both safety and efficiency. Slats are a testament to the power of smart engineering in aviation. The slat is truly a master of airflow, quietly working behind the scenes to make every flight smoother, safer, and more reliable. It's a perfect example of how a simple idea, when applied with precision, can transform the performance of complex machines like airplanes. That's the magic of the slat, a small feature with a huge role in making flight possible. Not all slats need pilot input. Some are automatic. On certain aircraft, slats slide forward or back based on air pressure, with no motors or hydraulics. At high speeds, air pressure keeps the slat retracted for smooth cruising. As the plane slows and the wing's angle changes, suction pulls the slat forward, opening the slot just when needed. This self-regulating system is lightweight and reliable. Automatic slats were used on WB-2 fighters like the Messerschmitt Bf 109, giving pilots better low-speed control. They allowed tighter turns without stalling, a big advantage in dogfights. While less common on today's big jets, automatic slats remain a brilliant example of passive aerodynamic design. Sometimes the forces of flight themselves are the best engineers. Some planes use fixed slats, permanently open slots at the wing's front. These are found on STOL, short takeoff and landing aircraft, designed for slow flight and short runways. Fixed slats are simple. No moving parts, no motors, just reliability. They're perfect for bush planes operating far from maintenance facilities. The trade-off? Extra drag at high speeds, making them inefficient for long-distance jets. But for planes that need to land almost anywhere, the benefits outweigh the drawbacks. Historic planes like the Fieseler Storch and modern light sport aircraft use fixed slats for amazing low-speed performance. These planes can land where others can't, thanks to this straightforward technology. Sometimes the simplest solution is the best. Fixed slats prove that rugged simplicity can open up a world of adventure. Massive airliners like the Airbus A380 need powerful, precise slats. These are powered by hydraulic or electric systems controlled by pilots from the cockpit. When preparing for takeoff or landing, pilots extend the slats using a lever, and computers ensure perfect synchronization across both wings. The system must be strong to move large, heavy slats against intense air pressure. Safety features and backups keep everything reliable. If one motor fails, another takes over. Pilots can choose different slat positions for various conditions, optimizing performance for weight, runway, and weather. Powered slats let giant jets operate safely from the same airports as smaller planes. This technology combines raw power with smart control, making global air travel possible. Powered slats are a marvel of modern engineering. The Slats invention was born from the need to prevent deadly stalls. In 1918, German engineer Gustav Lochmann noticed a damaged wing panel improved low-speed handling. He experimented with a separate airfoil in front of the wing and patented the slatted wing. Meanwhile, Britain's Handley Page developed a similar slotted wing and filed their own patent. After a legal dispute, both parties agreed to share rights. Early 1920s planes proved the concept, And by World War II, slats, especially automatic ones, were common on fighters. The Fiesler Storch used fixed slats for legendary short-field performance. The jet age demanded even more advanced slats for higher landing speeds. Today's complex powered slats are standard on airliners and military jets. From a simple observation, the slat evolved into a vital technology for safe, capable flight. It's a story of innovation that changed aviation forever. Nature invented the slat first, the bird's alula, or bastard wing. This small group of feathers acts just like a slat, creating a slot to keep airflow attached during slow flight. Birds use the alula to land precisely, hover, and make sharp turns without stalling. Watch pigeons or hawks. As they slow down, the alula pops up for extra lift and control. It's a perfect example of convergent evolution, nature and engineers solving the same problem. Birds control their alulas with incredible precision, inspiring modern wing design. Each species' alula is uniquely adapted for its flying style. By studying birds, engineers hope to build smarter, more efficient wings for the future. The future of slats may be wings that morph and flex, inspired by birds. Researchers are developing wings made from flexible materials and shape memory alloys that change shapes smoothly, without separate slats. Tiny actuators inside the wing would bend and curve the leading edge in real time. This would reduce drag, save fuel, and make planes quieter. No more noisy gaps or steps. NASA and others are already testing small morphing wing aircraft. The next generation of wings will be seamless, efficient, and organic, moving beyond traditional slats. The slat's legacy is inspiring even smarter, quieter, and more efficient flight. Sometimes, the best ideas come from nature and keep evolving.